flying over Buga. It's everywhere, it's viral, and it's sparking debate.
Find out what is this technology for the well of the people.
A mysterious metallic sphere discovered in Colombia is challenging everything we thought we knew about physics. Imagine an object that continuously absorbs 100 watts of energy from its environment without any visible source or loss, defying the fundamental law of conservation of energy. Could this be the key to revolutionary propulsion or energy technologies? Leading physicists, teamed with cutting-edge artificial intelligence models, have confirmed baffling phenomena. This orb not only draws energy endlessly, but appears to manipulate its own mass, changing weight without altering size. The implications of this discovery could redefine energy, gravity, and motion as we understand them today. Energy absorption anomaly. The Buga sphere's most startling property is its ability to continuously absorb energy from its surroundings.
The object now known as the Buga sphere has become the center of a growing mystery.
After extensive testing, MIT physicists confirmed that the sphere draws in roughly 100 watts of heat energy steadily over many hours. This kind of constant energy intake has no known parallel in either natural or engineered materials, making it a profound enigma. Typically, objects give off heat or reach thermal equilibrium with their environment, but this sphere behaves in a way that contradicts those basic thermodynamic principles. What adds to the mystery is that the sphere's surface remains cool to the touch, despite drawing in so much energy. When water droplets were placed on the orb during experiments, they evaporated instantly, mimicking contact with a hot surface. However, thermal imaging revealed no surface temperature increase, indicating that heat was being channeled internally and transported away rapidly. This suggests a complex internal mechanism moving energy through the sphere rather than dissipating it as surface heat. Researchers rigorously ruled out conventional explanations. If the object contained batteries or any stored power source, a drop in energy would have been observed over time, but none occurred. Similarly, cryogenic materials or phase-change substances, which could absorb energy temporarily, were dismissed because they would eventually warm or saturate, neither of which happened. This leaves the continuous energy absorption without apparent loss as a direct challenge to known physics. To put it simply, imagine a device like a refrigerator that never needs an external power source, instead pulling energy indefinitely from ambient surroundings. The Buga sphere appears to operate on such a principle.
How can a perfectly round metallic sphere with no wings, no seams, and no visible propulsion fly?
With no visible source or emissions, the MIT team emphasized that these are not approximations or speculative ideas. The energy flow was documented with calibrated, repeatable instrumentation under controlled conditions. Further observations showed that external environmental factors could not explain the energy intake. The ambient temperature remained stable and showed no fluctuations that might cause heat flow into the sphere. This rules out normal thermal gradients or weather-driven effects, reinforcing the conclusion that the sphere functions through unknown physical processes. The continuous inward flow of energy from the environment to the sphere perplexed scientists because it seemingly defies the foundational law of conservation of energy. This principle holds that energy cannot arise from nothing without associated costs or emissions, yet the sphere appears to pull energy in perpetually. Such behavior compels physicists to revisit some of their most basic assumptions or explore new physics beyond their current models. Following the confirmation of this extraordinary energy anomaly, researchers directed their attention toward another baffling aspect, the sphere's fluctuating weight, which appeared to defy conventional mass conservation laws. The weight fluctuation puzzle. One of the most perplexing discoveries about the Buga sphere is its changing mass over time. Initially, when recovered,
Buga sphere, a mysterious flying sphere recovered in the town of Buga, Colombia.
the sphere weighed approximately 4 to 5 pounds, but over weeks it gained weight steadily, first reaching 16 pounds, then climbing past 20, while its size and physical appearance remained unchanged. This conflicts with standard physics where mass and volume are closely linked, and mass generally cannot change without a corresponding physical process. Extensive experiments used calibrated laboratory scales to measure these changes accurately, eliminating errors caused by environmental interference or equipment faults. The increase occurred gradually, ruling out transient fluctuations or accidental contamination. Such a significant, sustained mass variation in an object not adding or losing material is unprecedented and suggests interactions with forces or fields currently outside accepted physics frameworks. The concept of mass changing without matter entering or leaving contradicts fundamental Newtonian and thermodynamic laws. Mass is conventionally understood as a conserved quantity, unless subject to known mechanisms like chemical transformation or matter exchange, none of which apply here. The sphere's rising weight alongside stable volume implies density alterations driven by unknown principles, pressing scientists to question deeply rooted physical laws. Significantly, the sphere's landing site exhibited ecological anomalies. Vegetation died, and ground remained barren for months afterward. Though these environmental effects do not directly explain the mass increase, they provide circumstantial evidence that the sphere's energetic or field properties extend beyond its physical form. Such influences potentially alter local matter or energy in ways we do not yet comprehend, tying together mass fluctuations with external interactions. Efforts to explain the weight phenomenon through conventional physics or hidden components failed. Advanced imaging and material analysis showed no indication of internal material changes or physical compartments that might add weight. This impasse motivated the scientific community to explore novel theories and leverage artificial intelligence models for deeper understanding. Practical implications of the fluctuating mass include explanations for eyewitness accounts of the sphere's erratic, high-speed flight patterns. By effectively reducing its inertia or mass temporarily, the sphere would require far less force to maneuver sharply, making its zigzag movements plausible under reduced mass conditions. This potential to modulate inertia hints at groundbreaking propulsion mechanisms. Understanding the mechanism behind mass modulation is critical, as it touches the core of physics and may open avenues for entirely new technologies. The weight fluctuation puzzle represents not just an isolated oddity, but a doorway to possibly revolutionizing our concept of matter and motion. To unravel these mysteries, scientists turn to one of the world's most advanced AI physicists, Grok 4, for analysis and hypotheses. Grok 4 AI Model Insights. Confronted with data that defied conventional explanation, researchers employed Grok 4, an advanced AI physicist built to analyze complex phenomena. Grok 4 ingested diverse datasets, including changing mass measurements, thermal behavior, electromagnetic readings, and materials composition to formulate a cohesive explanation of the sphere's characteristics. This cutting-edge AI approach introduced novel ideas beyond human intuition. The AI's bold hypothesis centers on an engineered internal lattice generating a negative mass effect. Negative mass, though exotic in theory, describes an entity that behaves as if its inertia is reversed, akin to carrying a backpack that somehow feels lighter as it fills up. Grok 4's calculations matched observed weight fluctuations by positing a lattice inside the sphere capable of producing the equivalent of about 8 kilograms of mass, effectively reducing the sphere's apparent weight by approximately 81%. This model explains how the sphere could perform highly agile, erratic aerial maneuvers without visible means of propulsion. Dramatically lowered effective mass means minimal force is required for rapid acceleration and sharp directional changes, making the eyewitness reports of zigzag patterns physically plausible. Intriguingly, Grok 4 predicted the sphere's continuous energy absorption of roughly 100 watts before MMT's measurements confirmed it, lending significant credibility to the AI's framework. Further X-ray imaging supports the AI's internal hypothesis, revealing 18 microspheres arrayed in concentric layers inside the orb. This intricate structure aligns with Grok 4's proposal that these microspheres form a network responsible for activating the negative mass field. The AI's explanation ties together the sphere's energy, mass, and propulsion anomalies into a single, coherent model. One of the most astonishing AI-driven insights is the suggestion that the sphere contains a built-in quantum computer or neuromorphic system. Grok 4 estimates this internal network executes up to 70 trillion operations per second, enabling it to regulate the sphere's exotic physics dynamically and maintain stability during complex mass and energy manipulations. This implies an intelligence or autonomous control embedded within the object's very structure. Grok 4's hypothesis shifts the discussion from mystery to possibility, envisioning a highly sophisticated device that manipulates space-time geometry and mass-energy relationships. This emerging picture presents a new realm of physics and materials science, with the Booga sphere as a tangible example of technology far beyond current human capabilities. Ongoing experiments aim to validate these predictions and explore replication of these effects, underscoring the opportunity to unlock unprecedented scientific and technological advances. With this AI-informed insight, researchers now turn to examine the sphere's internal neural-like network and how it orchestrates the observed phenomena. Quantum neural network theory. X-ray imaging of the Buga sphere has uncovered an extraordinary internal complexity that challenges conventional understanding. Inside the sphere lies a delicate network of fiber optic-like filaments woven throughout its core.
We found the wires for the fiber optics, but no wires inside the sphere.
These filaments form intricate patterns resembling a photonic neural network, which is a system that processes information using light, much like how neurons operate in a brain. This discovery suggests that the sphere is not merely a passive object, but may contain an internal intelligence capable of managing its exotic physical behaviors. Advanced analysis by Grok 4 predicts that this neural network could perform approximately 70 trillion operations per second. Such computational capacity would enable the sphere to regulate its energy absorption, mass fluctuations, and even its propulsion mechanisms instantaneously. This real-time control might explain how the sphere maintains stability despite defying numerous physical laws, employing complex feedback loops to continuously adjust its internal states. The idea of a built-in quantum computer or neuromorphic system places the Booga sphere in a category far beyond typical engineered devices. Its architecture seems to merge emerging quantum computing technologies with advanced AI capabilities, integrated within the object's very structure. This would make the sphere an autonomous entity, capable of independent operation and adaptation to its environment without external commands. Such a revelation challenges existing definitions of machines, life, and consciousness. Remarkably, the sphere's behavior also appears responsive to external stimuli, as videos show its vibrations intensify when exposed to certain sound frequencies. This suggests acoustic resonance might interact with its internal neural network or energy field, perhaps serving as a communication or control mechanism. If so, this interaction could provide a method to engage with or influence the sphere's functions, opening new avenues for research into device-environment interplay. Scientists are cautiously optimistic about these findings. If validated, this could represent the first instance of a technology integrating information processing directly into physical matter on such a scale. It highlights possibilities for future materials and devices that blend computation and physical effects seamlessly, potentially redefining what intelligent machines can be. The implications extend beyond technology, as this also raises profound questions about autonomy and the nature of intelligence embedded in non-biological forms. The photonic neural network may blur the line between living systems and engineered devices, forcing a reconsideration of how intelligence can manifest in the universe. Ultimately, the Booga sphere may represent a wholly new category of existence, an entity that blurs the boundaries between machine, organism, and quantum system. Early analyses suggest that its internal architecture might operate as a self-regulating network, capable of sensing, processing, and responding to environmental stimuli in ways reminiscent of biological intelligence. If confirmed, this would mark the first known instance of a material construct exhibiting both mechanical precision and adaptive, quasi-living behavior. Verifying the presence and function of this hypothesized quantum neural network will require advanced imaging, spectroscopic mapping, and controlled experimental testing under varied environmental conditions. Yet even at this early stage, the implications are revolutionary. The Buga sphere could embody the next evolution of technology, a self-sustaining hybrid intelligence that operates in harmony with its surroundings, merging the laws of physics, biology, and information into a single, unprecedented system. Turning now from the sphere's internal architecture, let's examine the tangible effects it has had on both its surroundings and human handlers. Environmental and human impact. The Buga sphere is not just a scientific curiosity. Its presence has measurable impacts on the environment and human health. One local, David Velez, who helped retrieve the sphere, reported falling ill for days with unexplained symptoms, including severe headaches and lethargy, shortly after handling the object. Medical evaluations found no conventional cause, suggesting the sphere emits influences that adversely affect biological systems. Beyond human health, the sphere's landing site remains uniquely barren months later, with no vegetation regrowth despite favorable conditions. Scientific measurements detected no harmful radiation that could explain the die-off, but there was a strong decaying ionized field surrounding the area. This anomalous field may inhibit plant growth or alter soil chemistry, indicating the sphere's energetic footprint has prolonged environmental consequences. Another notable observation is how water interacts with the sphere's surface. Despite feeling cool, the surface causes water droplets poured on it to vaporize instantly, demonstrating localized energy transfer powerful enough to change water's phase without heating the surface itself. This phenomenon suggests an active energy process that influences matter directly in contact, not merely through thermal conduction. These findings imply the sphere manipulates energy fields that can affect living organisms and ecosystems, raising concerns about safety and containment. If scaled or uncontrolled, such energetic effects could have wider ecological ramifications, emphasizing the need for careful study and ethical management. Interestingly, the sphere's behaviors echo patterns seen in other metallic orbs discovered previously. Similar environmental and physical impacts lend weight to the hypothesis that these spheres may be part of a broader phenomenon or network, rather than isolated incidents. This pattern demands serious and sustained scientific investigation. The sphere's profound environmental implications underscore that its extraordinary physical properties extend far beyond laboratory curiosities. They possess tangible, real-world significance. This realization compels the scientific community to approach further study with a balance of ambition and caution, recognizing that the same principles that promise limitless clean energy or near-effortless propulsion could also introduce unforeseen consequences. Understanding the risks and rewards of such unprecedented technology will be essential, not only to harness its potential responsibly, but also to ensure that its applications serve the long-term well-being of both humanity and the planet. The biological and ecological effects observed reinforce the sphere's extraordinary nature, linking its scientific mysteries with tangible consequences. With these realities in mind, attention now shifts to the wider implications and future research directions this discovery invites. Emerging impact and future research. The discoveries surrounding the Buga sphere carry the potential to revolutionize entire branches of science and technology. Early observations suggest that this object exhibits a continuous uptake of ambient energy
as the Buga sphere, a mysterious flying sphere recovered in the town of Buga, Colombia,
and an unprecedented capacity for mass manipulation, phenomena that defy conventional physics. Should researchers succeed in understanding and replicating these mechanisms, the implications for humanity's energy systems would be profound. Imagine devices that can draw power from their surroundings indefinitely, converting environmental heat or zero-point fluctuations into usable energy. Homes, industries, and even entire cities could operate without dependence on fossil fuels or centralized grids, ushering in an era of clean, self-sustaining energy that eliminates emissions and drastically reduces global energy costs. In the field of transportation, the sphere's ability to reduce its effective mass by more than 80% offers a tantalizing glimpse into the future of motion itself. Vehicles equipped with similar technology might require only a fraction of the energy needed today to achieve lift, acceleration, or propulsion. Such breakthroughs could lead to spacecraft capable of interplanetary travel with minimal fuel consumption or terrestrial vehicles that hover and glide with extraordinary efficiency. The result would be a paradigm shift in mobility, redefining the boundaries of aerospace exploration, high-speed travel, and even military maneuverability, domains where energy efficiency and agility often determine success. Yet, these advancements are not without their strategic and security challenges. Technologies that manipulate mass or distort energy signatures could render conventional detection systems, such as radar, lidar, and gravimetric sensors, ineffective. A craft capable of altering its apparent mass might appear invisible to standard surveillance, posing difficulties for air defense and tracking systems worldwide. Governments, defense agencies, and scientific institutions will need to rethink surveillance paradigms, developing new frameworks and technologies to monitor and regulate the use of such transformative capabilities responsibly. To unlock the mysteries of the Booga sphere, researchers are preparing a comprehensive series of advanced imaging and analytical studies. Neutron tomography and high-resolution computed tomography, CT, will be used to construct detailed internal maps of its structure, potentially revealing unknown engineering methods or exotic material compositions. Metallurgical and isotope analyses will probe the sphere's elemental makeup, searching for isotopic ratios or atomic configurations not found on Earth. These efforts could determine whether the object is the product of extraterrestrial craftsmanship, advanced human experimentation, or a new branch of physics altogether. Further experiments are being designed to test the sphere under controlled vacuum and zero-gravity conditions, determining whether its continuous energy absorption persists beyond Earth's atmosphere. Confirmation of such behavior would revolutionize space-based power generation and propulsion technology, suggesting that spacecraft could one day draw limitless energy directly from the vacuum of space. Parallel investigations into acoustic resonance effects, where the sphere reportedly exhibits harmonic responses to certain frequencies, aim to uncover whether vibration or sound could be key to unlocking or controlling its functions. Despite the unanswered questions surrounding its origin and intent, one fact is clear. The Buga sphere exhibits physical properties that challenge the limits of known science. Its study compels a re-examination of the fundamental relationships between energy, matter, and space-time itself. To engage with such phenomena responsibly will require humility, cooperation, and imagination, a willingness to expand the frameworks through which we understand the universe. Ultimately, the Buga sphere stands not merely as an artifact, but as a gateway to new physics and a potential turning point in human technological evolution. As research deepens, humanity faces both a remarkable opportunity and a profound responsibility to learn from this enigmatic object, to grasp the principles that govern it, and to ensure that the knowledge it yields is harnessed wisely and ethically for the advancement of all life on Earth and beyond. The Buga sphere challenges everything we know about physics, showing unexplained energy and mass anomalies confirmed by top scientists and AI. This discovery could transform energy, propulsion, and defense technologies in ways we are only beginning to grasp. Stay tuned for more breakthroughs by subscribing and hitting the notification bell to explore these extraordinary findings with us.